Of course, an angle is defined as an intersection of two rays at its vertex. And in the trigonometry class, we have a so-called initial and terminal side to determine the initial side to where the angle is drawn, and the terminal side to where the angle terminates. Again, we have an initial side and a terminal side. This initial side and terminal side are the ones that will tell us where we start. So the initial side is the line to where we start. The terminal side is the side of the angle to where the arrowhead points or to where the angle terminates. It is also the side to which the direction of the angle is being stated. Because in our lesson right now, we have negative angles. We do have negative angles. If you notice, the given in activity 1, activity 2, you have their negative angles. All the more that you need to learn these terminologies because an angle in standard position, take note, an angle in standard position of a certain angle in trigonometry has a specific initial side. The angle in standard position is drawn from the Cartesian plane where the vertex is in the origin, and the initial side of the angle in standard position is in the positive abscissa. Again, the angle in a standard position is starting or is to be started or will be started or will be drawn first in the positive abscissa, which is the positive x-axis. Remember the angle from a bearing? We draw the angle from the north, right? Which is in the positive ordinate or the positive y. But now, we move our point of reference to the positive abscissa or to the horizontal positive x-axis, and that is our initial side. The terminal side goes with anywhere in the Cartesian plane. And the terminal side is determined by the arrowhead of your angle. Again, angles in standard position are drawn from the positive abscissa, or the initial side is in the positive abscissa and turns to the terminal side anywhere of your graph. The direction of your angle could be counterclockwise or counterclockwise. If you notice in this frame, the direction of the angle from the initial to the terminal side is counterclockwise, right? Which means it's against the clock, counterclockwise. If the angle is drawn in a counterclockwise direction, the angle is positive. Again, if the direction of your angle drawn from the positive abscissa is in counterclockwise direction, sorry for that. If your angle drawn is in a counterclockwise direction, which means from positive abscissa turns counterclockwise, the angle is said to be positive. If the angle drawn is drawn from the positive abscissa and it goes in a clockwise direction, which means it follows the movement of the clock, then the angle is negative. Therefore, negative angles goes with the positive abscissa drawn in a clockwise direction. Negative angle is an angle drawn from the positive abscissa with a counterclockwise direction. Let's have an example and sketch these angles. If you don't have a question, let's proceed then. Okay, let's proceed. Here we have three angles, 240 degrees, negative 50 degrees, and 500 degrees positive. What is the value of the angle in each quadrant again? If we draw the angle of a quadrant, each quadrant measures 90 degrees, right? And the measure of 90 degrees in numeric is going to tell you of a right angle. The half of it is 180 degrees, and one complete revolution is 360 degrees. Therefore, if your angles is more than 360, then it will continue the revolution. Depending on how many revolutions is also the angle reflected in the standard position. To start off, let's have letter A. In letter A class, you have positive 240 degrees as your standard angle. Question: which direction is it thrown from the positive abscissa? Counterclockwise or clockwise? Daniel.
Counterclockwise, sir.
Very good. Counterclockwise direction. In letter B, positive 500 degrees. What is the direction of your angle, Ralph? Clockwise or counterclockwise?
Counterclockwise, sir.
Counterclockwise still because it's positive. What about letter C, Risha? The angle is negative 50 degrees. So where do you think is the direction of your angle?
Clockwise.
Very good, clockwise direction. So let's try to, thank you, Krisha, Ralph, and Daniel. Let's try to proceed with drawing letter A. To draw letter A, class, we have this as our angle. The red direction or the red color pertains to your standard angle. No? Just to specify the 60 degrees, because this angle here is 180 degrees. Huh? And then if you add 180 to 240, it will result to, 180 and 60, that will end up with your standard angle, 240 degrees. The name of 60 degrees, by the way, class, is a reference angle. There's a chat from Clarice. Yes, Clarice, I will do so. I will. After my class, if I can manage
Thank you,
to
sir.
upload both videos, I will give it to you then in Edmodo. To continue, class, we have the green colored angle to represent the acute angle of your standard angle 240 degrees. In our next lesson, which is not now, 60 degrees is the reference angle. Again, 60 degrees is the reference angle. But for now, just leave it hanging. You don't need to worry about what is a reference angle or what is not a reference angle. Question regarding letter A as to how we are going to draw it. We started with a positive abscissa. Since the angle is positive, we turn counterclockwise direction until the third quadrant. This is just an assumed position of the angle. For as long as the angle is located in the third quadrant, then your answer is safe. But if you draw it until the second quadrant, and this is your 240 degrees, then probably there's something wrong with your answer. Because 240 degrees is more than 180 degrees, which means it's a reflex angle. Question regarding a letter A. Let's compare letter A, class, to letter C. I will solve letter C for now. So in letter C, the angle given is negative. So this is your drawing. From the positive abscissa, it turns in the clockwise direction. And since 50 is acute angle, so it's less than 90 degrees, so we'll end it in the fourth quadrant. Review for quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Questions for letters A and C?
Again,
No.
sir, why do we have to put negative 50 below, sir?
Okay, let's go back to the definition of angles. If you draw angles in the direction which is clockwise, your angle is negative. So if the angle is negative, then if the given angle is negative, you will draw it below the positive abscissa. That is why in our letter C, we draw the angle below the positive abscissa because the given is negative 50 degrees. Again, do not worry yourselves if you are still having a hesitation to understand this because in our next lesson, babalik tayo dito. It's just that I wish you to realize why is it that in my given there are negative angles. Get it? In letter D class, it is more than 360 degrees. So expect that in letter D, there is more than one complete revolution. And indeed, you have one complete revolution plus 140 degrees more. So from the positive abscissa, the counterclockwise direction. So until here is 360. But our angle is 500 man, so we have to go 140 more. So there you have the angle at 500 degrees. Questions? Clarifications? Okay, I think there is a little understanding since most of you are silent or not. Then again, I will repeat this discussion in our third module. So no need to worry yourselves. It's just to give you a little headache for now. Let's try to draw the angles in standard position. To start off, we have 65 degrees. 65 degrees. I will draw it here. Okay. So 65 degrees is like this one. From the positive abscissa, turns counterclockwise direction, so that is 65 degrees. Number 2, from the positive abscissa, turns counterclockwise direction, so this is 300 degrees. Number 3, negative 120 degrees. So the direction there goes clockwise direction with more than 90 degrees. So there you have your 120 degrees negative. These are just assumed positions again, not exactly drawn to scale because I don't have a protractor in mind. Last number 4, since this is more than 360 degrees, so from the positive abscissa turns clockwise direction being the given negative. So we have until here is 360. Subtract 450 by 360, you'll get 90 degrees. So we have to go 90 degrees more. So this is your 450 degrees negative. Please copy and ask a question if you have one. My forehead is already shining, shimmering, splendid because of the rays of the sun.
By the way, now that we are also doing this, you cannot do.
Okay, I will eliminate my solutions. Let's proceed then with Angles class. So the main concern of, I will skip these parts because this is not yet our concern class. The concern right now goes with this one. Converting degrees to radian or radians to degrees. Again, we need to convert degrees to radian, radians to degrees. In your module class, you have here words like 1 radian, 2 radian, 3 radian, until 6 radians, and so on and so forth. But if you are going to focus your attention on the conversion, we can just simply, even without the graph, we can determine the conversion of that degree measure to radian measure since we have these. that we can use. Read your module. Somewhere in the bottom of the box, you have there conversions between degrees to radian. To convert degrees to radian, multiply the degrees by pi rad over 180 degrees, which is this one. And converting radians to degrees, multiply the radian by 180 degrees over pi rad, over pi rad. Let me make use of your module as an example so that it will be just going directly to notes taking. So we have here an example. Convert 60 degrees to radian measure. It's just that here we did not have the word rad, but it's always present in the solution class. Ano siya rad? It's just I forgot to write it there. There's pi rad there, and then there's also rad in the final answer. Okay, so here we also have pi rad. And then here we have the rad. Okay. So from the examples, to convert radian to degree measure, we have to multiply it with a pi radian over 180 degrees. It's just that the degrees here are not anymore written because it is now cancelled. If you write the degrees here, class, notice this given. There is a degrees in the original as so as with the denominator. But if you are going to focus your attention in simplifying this expression, degrees can be cancelled. Degrees will just be cancelled. Right? So it's just as if we need not to write the degrees there. Just go directly in eliminating the degrees. And then calculators will do everything here, class. 60 divided by 180 is 1/3. So your answer is 1/3 pi rad or pi over 3 rad. Let's try to have an example in your activity. Choose the number and then we'll solve it.
If I'm not mistaken, it will be
Activity 2, activity 2. Let's try number 2.
5, sir.
Yes, number
Number 5, sir.
2. Very good. Number 2. Number 5. Okay. Wala talagang gusto sa number 2, no? Number 5, the given is negative 545 degrees. What's the rule there? To convert degrees to radian, we multiply it by pi rad over 180 degrees. So that is what we're going to do here, class. We multiply this by pi rad over 180 degrees. Follow? So the solution then goes with negative 545 pi. Sana si pi? Ayun. Over 180 radian. What happens to the solution? We just had to multiply 545 by the numerator whilst eliminating the degree sign. Now, it's just as easy as pressing your calculator. What is the result when you divide or when you press 545 by 180? What's your answer there?
109 pi over 36.
Very good. You have 109 pi over 36. And do not forget, with or without the radian, it's still fine. It's just for safety purposes, write the rad. Question?
Go with.
Clarification? Now, I ask you this time. Is the lesson hard or not?
It's not hard, sir. It's just confusing.
What's the
Simple.
I'm not sure of how to understand it. It's not
Rad,
hard,
sir.
it's just confusing.
Sir, how to convert again, sir?
The
How
rad.
to convert? Now, let's try another example then.
Sir, where's red, sir?
Here, Rad.
No. In the calculator, sir.
In the
Well, no, there's none. There's no rad in the calculator. It's just the mode of your calculator. If you notice in your calculator, somewhere on top, you have the letters D, R, and G. It's just that in this given, we don't need to write the word degree. But if you don't have the symbol, you can write here as degree. 365 degrees. But since we have the symbol for degrees, then why not use the symbol instead of the word? But in the concept of rad, we don't have the symbol for rad, so we'll just have to use the word rad, which means radian. In your calculator, again, going back to my point, the calculator has three modes, the DRG, which means degrees, radians, and gradians. As of now, your calculators in refresh mode are in degree measure. If you're going to change it to the radian measure, then multiplication of numbers will give you a different answer. So it's safe to say that we'll just have to go with degree measure there. So in activity 2, the answer must be a fraction. No, you may not express this in a fraction. So if you wish to express it in decimal class, feel free to do so. Like for example, let's express this answer in decimal. So this will be equal to negative 3.03 pi rad. You can have that as your answer. Also, if you wish to eliminate the pi, you can multiply 3.03, again, 3.03 by the value of pi. We will agree on the value of pi and we have to have it as 3.14. So simplify the answer now by multiplying 3.03 by 3.14. So you get the answer 9.51 radian. All of these are acceptable. Whether you answer it in fraction, whether you answer it in decimal, or whether you answer it in decimal without the pi. Please see the difference. They all but have the same result. They are all considered correct. But why bother yourselves extending it into a decimal when there is an immediate answer in your calculator which is in a fraction form? Okay? So stay simple with your solution. In case your calculators does not give you a fraction, do not make it a problem. I will accept decimal answers. One last example. One last example. Excuse me, sir. Where did you get 180 degrees in number 2 again? Let's read the module again. In the concept of conversion class, one complete revolution, which is 360 degrees, is equal to twice the value of pi. How will you get this 2 pi? Circumference of a circle is equal to 2 pi r. So therefore, the ratio of the circumference and the radius is twice the pi. Geometrically speaking, pi is going to represent the relationship between circumference and diameter, because if you have radius that is twice the diameter, with the value 3.1415, 3.14159, until and so on and so forth. No? So we get that relationship as 360 degrees is equal to twice pi, and then divide both sides by 2, you'll get 180 degrees is equal to pi, which is now present in the table. 180 degrees equals 1 pi. Just like conversion class, convert 30 centimeters to meters. So we will multiply it by 1 meter is 100 centimeters. You may ask a question, where did you get 100 centimeters, sir? That is the equivalent value of meters to centimeters. So when you ask me a question, where did you get 180 degrees, sir? The relationship that exists between 1 pi radian is equal to 180 degrees. 1 pi radian is just equal to 180 degrees in the other mode of measuring an angle. And that is where we get to use to come up with a conversion factor. Just like the same as in this case, since our given is degrees, so we will multiply it by pi over degrees. And in this case, 180 degrees is equal to 1 pi radian. So to eliminate the unit, which is 60 degrees, we have to put the 180 degrees in our denominator. Question? If you just read your module class and then focus your attention on that discussion, I think this is not a difficult task to do. Because if I were to give you an idea, class, if I will just have to give you some thoughts on the previous batch on this lesson, everyone in this lesson, when I gave them the summative test, was perfect. Because it's just simple, it's just as simple as conversion. Last example for converting degrees to radian.
Sir, I have a question, sir.
Yes, Daniel.
Will you include the angles, like determining the angles in the ST, sir?
I did not actually get your point. Determining the
Like
angles in
the
an ST.
like the
First
positive,
one is
the
not
first.
asking.
No, no,
Yes,
no, no,
sir.
no, no.
Okay.
The concern of our module right now is conversion of degrees to radian and radian to degrees. The initial discussion on negative and positive angles, such that you will be guided why I gave negative angles here. Because this lesson is now the introduction of standard angles. And standard angles can be positive, it can also be negative. Get it? But if the concern of Daniel is in the upcoming ST, will we have also the negative and the positive angles? Do we draw these angles? The answer is a no. You have to convert. That's your main purpose of this lesson. Any other question? Okay, none. So let's proceed with another example. Choose between 2, 3, and 4. Number 4? Let's try number 4. I just chose it myself. Number 2? Let's try number 2. Walang mag-react, I'll go with number 2. 330 degrees is our given. This is number 2, ha? Paminaw tong daghang pangutana. Now, if you can just turn on your cameras, it's safe to say that you're listening to my discussion. Let me see your faces and I can say they are listening to my discussion. If I can only see a portion of your head, then probably the next time you're going to ask me a question, I will not answer your questions then. 330 degrees is the given. So in converting degrees to radian measure, we multiply the degrees by the conversion factor. And the conversion factor is 1 pi radian is equal to 180 degrees. Where did you get that conversion factor, sir? Again, here. There is a rule. Sir, why do we have to follow the rules? Because that's the rule. We cannot do anything about it. Just like the same as no crossing of the street with the green light is on. Something like that. If you don't follow the rule, eventually it will give you a problem. Looking at the solution, class, let's cancel the degrees symbol and multiply 300 degrees by 1. So you have now 300 pi divided by 180 radian. What did, what did we do? Cancel the degree symbol. Question before we proceed? Now,
None,
press
sir.
your calculator. Do you have a calculator? Press it. 300 divided by 180. Whatever the result of your calculator, copy it. 5 over 3 is the answer, right? But take note, we still have pi and the word radian. So
Sir,
your
it's
final answer is
330,
It's
sir.
it's 330. It's mine's 11 pi over 6, sir.
yeah. My given is 300 degrees. It's supposed to be 330. So therefore, you are now listening to me because you thought you saw my mistake, and thank you for that. So this is not 5/3. Instead, this is 11 over 6.
11 pi over 6.
11 pi over 6. Question? Mine gave a decimal, sir. Yes, you can have the decimal again. If you have the decimal, Shania, do you mind? Give me the decimal. 1 point. Ah, you're typing it. Oh, 5.24. 5.24. My answer is 1.83 pi radian. That's my answer. Not 5 point, uh, 5.24. Ah, yeah, I know. Probably you multiply 1.83 by 3.14. I think this is the reason why your answer is like that. So let's multiply 1.83 by 3.14. Ah, yes. That is not 24 but 74. 5.74 or 75 radian.
Mine lagi, sir, is 5.76.
Ah, 1.83 times 3.14.
I'll try it again, sir.
You try. Do not use the pi in your calculator, class. We agree that the pi is only having a value of 3.14, right? Your calculator is complete with all the data there. 3.1415921.
Yes,
I
sir,
don't know the rest.
5.75.
Do not use again the pi in your calculator, ha? Instead, if you wish to have the decimal, use the value of pi at 3.14 only, so that we will have the same answer. Okay, question time. Question? Yes, Clarice.
I don't have questions, sir.
Sorry, I thought you was about to raise the hand. Yes, Shania. Yes, Shania. We will multiply it with 3.15 14 after. Or lagi. Okay. With respect to the final answer, you can have this as your final answer, or this one, or this one. Sir, asa may best nga answer? Para nako kinin siya. But there are calculators that doesn't have the display which is in fraction, so it could go with or of these, any of these. You may not show all answers from here until there, but just express one of these, then that is then the correct answer, final answer. If you are going to express your answer in decimal, make sure that you rounded it off correctly. Another question?
You want to know
Sir,
behaviors of
Yes. Sino
how
yun?
about radians to degrees, sir?
relationship.
How about radians to degrees? After this one. After this one. So pag wala ng tanong sa degrees to radian, punta na tayo sa radians to degrees kasi malapit na yung time. Baka wala na naman tayong time nito. So wala na tanong. Let's proceed to radians to degrees. In radians to degrees, we just have to multiply it by this value. 180 degrees divided by pi rad. But actually, this rad is not there. It could be present or absent here. But if the given has rad, then place the rad in the solution. So between numbers 1, 3, and 8, or 1, 5, and 8, which item will I solve? I will solve number 1. 3, 5. Oh, what is that? So in number 1 class, the given is 3 pi. To convert radians to degrees, very clear in the instruction here. Multiply it by this value, 180 degrees by pi radian. Question? Okay. Class, by looking at the solution, you will then determine, or you will then know who will be in your denominator and who will be in your numerator. With the idea of the unit to be cancelled must be in the numerator and the other one is in the denominator. So it's just like that. Which means to say that in your solution right now, upon eliminating the unit, you can go with 3 times 180 degrees. And multiply 3 and 180, you'll get 540 degrees. Question?
I'll get sa my charger, sir, kay may iPad slow bat na.
Later on, the scope limitation. That's where the scope limit. You know that one, take note of the
Questions?
scope limitation. Does it actually the part say that scope limitation?
Excuse me, sir.
Yes. Who is that? You cannot see. Identify yourself.
Krisha, sir.
Krisha, yes, Krisha, yes, Krisha.
Um, can we have one as example? Can we try number 5, sir?
Okay, let's try number 5. Now, I will make number 5 the last example. I think Krisha noticed something in the example of number 5, right? If you look at number 5 class, between number 1, number 6, number 10, and number 8, number 5 does not have pi. Right? Yes, sir. Okay, so let's then proceed with another example. This time, I will not use the given. I'll just have it here. Some other examples.
Try to check.
2 pi over 5 radian. Convert 2 pi over 5 radian in degree measure. So what will we do? Multiply it by 180 degrees over Okay. Multiply it by 180 degrees over 1 pi radian. Cancel the pi and the radian. So in this frame, you can cancel the pi and the radian. So your solution will go with 2 times 180 degrees over 5. Simply plus your calculator, 2 times 180 divided by 5, you'll get the answer 72 degrees. As easy as that.
The fourth one that I'm seeing is why is there a need for simply complex term? You're already assuming that there will
Another example. 7 pi
sibling conflicts may necessary, but
7 pi over 2 radian.
when you put that kind of question in your interview,
Allow me to share a shortcut here, class. But this might not be a sound example if you are going to be confused again. If you are going to express radians to degree measure, it's just as if the pi is replaced by 180 degrees.
one of my behaviors is that I get to be in conflict with them. I would tend to
Just like the same in the example here. From the pi, it was just replaced by 180 degrees. No need with the complexity of the solution. You just have to multiply 7 to 180 and then divide it with the divisor, which is 2. So the answer is 630 degrees.
that conflicts should arise.
Okay?
So, sir, excuse me,
Yes,
sir.
yes, yes.
And the ones that doesn't have pi, it's just the same, right? We'll just have to really just substitute it with 180. Like in the examples, it doesn't have pi in it ba?
We will solve it then. Para everyone will be clarified and not only April, okay? So together with the understanding of that example, April, I will direct your attention to number 5 in activity 1. So are we ready? Let's solve. Okay, let's have example number 5. The given is 12 over 7 radian, right? Still, we are going to multiply it by 180 degrees over 180 degrees over 1 pi radian. But if you look at it, class, the given does not have pi. In the examples below, we can eliminate pi here and pi there. Right? So nawala na si pi. But in this example, we don't have pi in the given. So how can we do something about this one? What can we do with that pi here? Any suggestion? I'll give 1 point for those who can give me the correct answer. What will we do with pi here? Oh my God, everyone is stopping. Oh, am I still heard?
Prepare them on Thursday.
With the pi here, class, where in fact we don't have a value of pi that can be eliminated in our numerator or anywhere else in the given.
3.14.
Very good. We will make this into 3.14. As such, we don't have a problem at all. What will we cancel is just the word rad in the numerator and in the denominator. So by eliminating rad, your solution will go with 12 times 180 degrees over 7 times 3.14. And what is next there, class? Everything is done in your calculator. Press your calculator and the answer there is 12 times 180 divided by 7 times 3.14. That is
98.22.
very good.
98.22
98.27. 27 lagi ho. Why is it that?
20, 27.
Why is it 22 years, Daniel? May know the answer?
It's
Why is it 22?
An angel, please allow me to do the edit.
Do we have 22?
Requirements of what an
Or
iron should look like.
I know why 22 yours. Because you are using again the pi in your calculator. This is the part where I have to repeat again and again and again and
okay.
again and again and again
It's
and again.
98.27, sir.
And then in the exam, someone will commit the same mistake again. Okay, clarifications regarding the solution of number 5. So for those without the pi, change the pi to 3.14. For those with pi, be happy because that pi will just be eliminated by the denominator of your multiplier 180 degrees over pi radian. Review your modules, class, because all the things that I am telling you about right now, you have there in your module as an example. The ones without the pi and the ones with the pi. With respect to how you are going to present your final answers, that is again dependent on your own decision. Should you wish to express your answers in decimals, feel free to do it. Should you wish to express your answers in fractions, then that would be highly appreciated. However you present your final answers, for as long as it is rounded off properly with all the units there is, then I will consider it correct.
And when we're talking about challenges,
Krisha, do we have some questions there? We understand, Krisha?
Yes, sir.
Thank you, Krisha. Rainiel, hindi ko naririnig si Rainiel. Rainiel, do you have a question, Rainiel? Did you understand, Rainiel? Yes, sir. Okay. Rainiel answered with the voice of Sir Jet. So pag wala nang tanong, then that will be all for today. Goodbye, everyone. See you on Thursday for the checking of your
Bye.
Bye.